So the first thing I want to do is give you some idea about the extent to which students are considered academically underprepared for college-level math. And so the data I'm drawing from is the most recent national data we have. It's from the 2003 cohort. They were tracked to 2009 it was a study by the U.S. Department of Education, and they sampled students across the country so that they could come up with a nationally representative sample. And 2003 is the most recent cohort we have. So for the 2003 cohort, 60% of those students who started at a public 2-year took a remedial math course, and 17% took a remedial English course. The numbers are a little bit better when we look at public 4 years, but still 1 in 3 students who started at a public 4-year took a remedial math course, and 7% took a remedial English course. And remediation is everywhere. It's at all types of colleges. So at the private nonprofit 4 years, not for-profit 4 years, private nonprofit 4 years, 22% of students took a remedial math course and 9% took a remedial English course. And I don't have the numbers up here for the for-profits, but the remediation numbers are a lot higher, actually. They're around the public 2-year numbers. So clearly, remedial math course taking is much higher than remedial English. And even though we're looking at the 2003 cohort, if you look at today, specific states or higher education institutions and you calculate these numbers, they're about the same. They can be a little bit lower, a little bit higher, but these numbers are not going away or looking that much different. So then if we want to look at what percentage of students earn credits for a college math course. So this is reflective of passing a college math course. And so among students who are pursuing an associate's degree, a 2-year degree, 47% of the total cohort were able to earn credits and pass an introductory math course, usually college algebra, and 9% were able to pass a calculus or an advanced math course. So what happened to the other students? They either dropped out of college, they failed a math course, they don't have credits in a college math course. If you look at students pursuing a 4-year degree, again, we see better numbers. So 66 or 2/3 of students who were pursuing a 4-year degree passed an introductory math course, and 34% passed a calculus or advanced math course. So there's a big difference between students pursuing different degree types, but the numbers, are not even close to 100%. So there's some work to be done there. And then the last thing we're going to look at is persistence in a STEM major. So we all know there's all sorts of consequences for not completing a college math course. You're less likely to be able to graduate, and it can have implications for the types of employment that are available to you. And another consequence is just in students' interest and persistence and completion of STEM majors. So we're looking at the same data. So for the 2003 cohort, 28% of 4-year and 20% of 2-year students began college as STEM majors, and 6 years later, we have, among AA students, 37% of those STEM majors dropped out, 1/3 switched majors, and about a little less than 1/3, 31% persisted and completed their STEM major. Among students pursuing a 4-year degree, 1 in 5 dropped out, about 28% exactly switched, and about half were able to persist. So half of 28% is a relatively small proportion of students actually earning a STEM degree. And so this, not only does this have implications for students, but also for the American economy, because we need to grow our science and technology industries to, grow our economy and to be competitive globally. So this is a third set of data for you to think about. And a brief aside before we get into the research. So this is nothing to do with math. This is about research. So I'm only going to present rigorous research today, and what I mean by that is research that can identify the exact effect of the precise impact of an intervention. So say you want to see what the impact of carrot juice drinking is on an individual, and you observe that individual has healthy heart outcomes, and so you think, oh, that's the cause, carrot juice drinking. But what if all the carrot juice drinkers were just led a healthy lifestyle? And so it's really impossible to tell if their healthy heart outcomes are the effect of the carrot juice drinking behavior or the healthy lifestyle. And this is a problem that in research we're trying to address all the time. How do we actually tie an intervention to an outcome? And so there is tons of research out there on math interventions and reforms. That's why the original paper is 70 pages long, and it has all that research in it. But what I decided to do for the brief was just to narrow it down to the studies that were pretty good at, or very good at, tying that intervention to the outcome and telling us about the precise impact of that intervention. So I'm only going to talk about rigorous research today. And what I mean by that are randomized controlled trials and quasi-experimental designs, which had a treatment and control group who are very similar, and so that we can really know what impact that intervention had, and it didn't have to do with any other thing going on in that student's life. But the drawback of that is that there's very limited generalizability of findings from these studies. They took place in a specific context with a specific population, and so we don't want to think, oh, they didn't work for this population, we're not going to consider them at all for our students. I think the benefit of this research is that we can be confident in the results, and they tell us a story about what happened in that specific context, and they'll help us think about how can we adapt that for our context if we're interested in that reform or intervention, and make sure that improve them so that they maximize their impact for students. And so, again, there's going to be limited research I'm presenting, but it's really only randomized controlled trials and quasi-experimental designs. Everything else is not in this presentation, right? Okay, so we're going to get into strategy number 1, intervening pre-matriculation. So that's intervening before students start college, and I'm going to talk about the definition of each intervention is how they're typically implemented across the country. So in your brief, there's some little short definitions. Those are kind of common ways that people are using these terms and implementing them. So the first is early assessment, which is basically an assessment given to high school students to get an early indication of their readiness for college. And there's a national scan, and right now 25 states across the country have statewide early assessment programs, which means all high school students have the opportunity to take a statewide assessment that tells them what they're, if they're going to be ready for college at a specific statewide university system. So I'll talk about the California Early Assessment Program in a little bit. And then 25 of those states also have, 8 of those 25 states have transition curricula, which means that students who do not test college ready have the opportunity to take courses in their senior year to brush up on skills that they have academic deficits in, and so that they can retest and see if they can test into college level courses. And so those might become, statewide early assessment programs may become more common with the implementation of PARCC and Smarter Balance in states that have adopted those, because those are essentially an early assessment of college readiness. Okay, then we have bridge programs, which have a long history in higher education, and Joan was telling me that University of Alaska has had them since 1970, so the summer bridge?
Not bridge programs, but other things.
Okay. Well, they have a long history in higher education. They're typically a month long. They happen during the summer, usually for students who place into remediation or students going into a STEM field who aren't ready for that STEM math course. And they brush up student skills, and they orient them to college life and give them some college knowledge. And then we have boot camps and brush ups, which are, a national scan showed they're fairly popular at community colleges. They're fairly low cost, easy to scale up. And boot camps usually last a week. They're similar. They're targeted to students who place into remediation, and they're given to them to brush up on their skills and orient them to college culture. And brush ups are usually just a few hours long. They're maybe an online course or a course given to students who don't do well on the placement exam. Okay, so This is the evidence. There's 2 rigorous studies. The first one was of the California Early Assessment Program. And so the main component of the California Early Assessment Program is that high school juniors have when they take the state standardized test for high school exit, they're given the option to take test items at the end of the test that were developed in collaboration with high school teachers and the California State University system. And those optional test items test their readiness for college-level coursework at the California State University system. And the community colleges have also adopted them. Those high school juniors receive a feedback form that says you tested ready in college-level coursework. If you go to CSU, you will automatically be able to enroll in college-level coursework. Or you didn't test ready, you need to do something about that in your senior year. So in this study, the researchers found that this program has a small positive impact on lowering remediation rates and they looked at California State University, Sacramento specifically. And they found that students were about 4 percentage points less likely to place into remediation and 4 percentage points more likely to place into college math. And they hypothesized that more students were doing something in their senior year to brush up on skills in order to place into college math. And so I have a question mark on positive impact because it's not clear the mechanism underlying early assessment. So early assessment is simply an assessment given to juniors usually. And so it's not clear how it's working to decrease remediation rates or, make them more likely to start college and college level math. But it may have an impact on their learning if they're actually taking more math in their senior year. And then there was a large-scale randomized controlled trial in Texas where they took recent high school graduates who had placed into remediation at 2 community colleges and 4 community colleges and 2 open access 4-year colleges. And they randomly assigned them to a summer bridge program or to nothing at all. They could just spend the summer doing whatever they wanted. And then they tracked them through the summer and over a 2-year period. And what they found is that, and this was a fairly intensive, a month-long summer bridge program. They were given academic courses. They were given a stipend to incentivize them to stay, and also some college knowledge curriculum. Students at first seemed like they were enrolling in college math, passing college math at higher rates than the control group who didn't have a summer bridge program. But after 2 years, there was no difference in any outcomes between the treatment and control group. And this was a fairly expensive randomized controlled trial and program. And so I think the overall lesson is that these programs that focus on improving placement test performance may have little effect on students' long-term college success. And short-term programs, you can't expect them to have a long-term effect. And also, this took place, again, in a specific context, so it's unknown what would happen if it was somewhere else with different students or in a different area of the country. But interestingly, many of the people involved in this program are now looking at another type of bridge program in the state of Washington in which students it basically starts in students' senior year where their college readiness is assessed, and then they start brushing up on skills in their senior year in high school. If they're still at the end of their senior year behind, they take a summer bridge program, and then there's supports that go all into their first year in college. So it's kind of a long-term set of supports that are given to students, and they're going to look at how those effects might be different than a summer bridge program. Okay, so I'm going to take a breath here and let you all talk to each other. I'm just going to give you a few minutes to talk about your experiences with early assessment bridges, boot camps, and brush-ups. If you have any student success stories or lessons learned about, challenges implementing them. And if you don't have any experience with these programs, or if you want to answer the second question, it's what is key to developing and sustaining strong partnerships between high schools and colleges. So many of these programs require partnerships. So how do you develop and sustain them? And I'm going to give you a few minutes and then ask for a couple people to share what they come up with. So go ahead. College systems that are going through system-wide reform. And, I'm also very passionate about this because I was a developmental education instructor, so I come at this topic with a lens of thinking about my students and that experience, which was wonderful. So the first model we're going to look at is learning communities, which is when students enroll in 2 or more courses together in the same semester. And out of all the reforms, this has the longest history in higher education. But interestingly, in all these developmental education reform efforts, learning communities are not discussed as much because they're not really considered an acceleration strategy, a strategy to accelerate students' progress through developmental education. But they're still probably more common than the other 3 I'll go over. The next is modularization, which is typically when they take a semester-long math course and break it up into discrete units or competencies, and students only work on those units or competencies that they haven't mastered yet. And it's usually delivered through some computer-based software. The third is compression. So compression is probably the most, another national scan found that compression is pretty popular for in developmental education reform right now. So basically what compression does is it takes developmental math sequences, and I know I'm preaching to the choir on a lot of this stuff, and a lot of you are involved in this, but developmental math sequences can be 3, 4 semesters long. So it takes 2 years to get through them if you're placed at the lowest level. Or 1.5 years if it's a 3-semester-long sequence. Compression takes 2 or 3 courses and compresses them into 1 semester. So it might take 2 courses that are each 4 contact hours, and now students have to take 1 semester-long course that's 8 contact hours. So the idea is that it's eliminating opportunities for students to drop out of the sequence and be pulled away for one reason or the other. And so the visual is basically compression. You have the compressed pathway and the traditional pathway. So, and usually they maintain the same contact hours. Sometimes they reduce them, but a lot of times they're just, it's basically a really long course that students take in a semester. And then finally we have mainstreaming, which is when students are or students who place into developmental math are allowed to enroll in college level math and take a support course concurrently that addresses their academic deficits. And this is much more common in English than in math, but I have a couple of studies on it from math. But it's the Community College of Baltimore, CCBC, Community College of Baltimore County, has a compression or mainstreaming English model that's kind of being replicated across the country, and so does a few colleges in California. So in math, not so much, which is an interesting thing to think about. All right, so here's a little bit more evidence. So it's going to take a little bit of time to get through this slide. So, put my pen down. There's one randomized controlled trial of learning communities, and there are 6 colleges, and 2 of those colleges decide to pair a developmental math course with a student success course. And they found that students in the learning community were more students pass their developmental math course than students in the non-learning community, the traditional developmental math course. But then after tracking their outcomes over time, there were no differences between the students in the learning community and the students who weren't in the learning community. And so they had the same college math enrollment and pass rates, the same credit attainment and persistence. So the effect was really, really isolated to that semester in which they're in the learning community, but there weren't any long-term impacts. Interestingly, though, there's also an English learning community that was also in this study, and this English one had some really long-term impacts on even degree attainment, and it was at Kingsborough Community College in New York City. And one of the biggest difference between the developmental English and there was also a college English learning community, and the math one was that they paired 2 courses, the English course with 2 other courses. So students were in 3 courses together. So the cohort model was kind of exponentially bigger. And they also, the other big difference was they think that there's more curricular integration between the 3 courses. So it really matters how these interventions are implemented, a lot. And you just can't, a learning community is not the same as the next one. Then we have modularization, and so this study took place in Tennessee. It was at Jackson State Community College and Cleveland State Community College, and the Tennessee redesigned their math courses, and those two colleges decided to take their semester-long developmental math courses and turn them into modules that students work through through computer-based software. And the redesign initially had a negative impact on students' persistence. The students in the modularized courses were more likely to drop out. And then over time, there was no difference in persistence and credit attainment between the students in the modularized courses and students in the traditional math sequence. So that initial negative impact is hard to figure out what happened. So it could have been the change in curriculum, which meant the curriculum was modularized, or it could have been the pedagogical change, which was the instruction, the content was delivered through computer-based learning. And perhaps, there wasn't enough instructor guidance or structure to the course, or students didn't know how to use the software. There's all sorts of reasons why students have a hard time adapting to courses that are delivered through computer-based software. And this is a really popular reform, and other research could find different things, but this is in a very specific, a couple community colleges. And then we have compression. So there's been two studies, and there's a compression model at the Community College of Denver called Fast Start. They've been doing it for quite a while, and they have some fairly positive results. So students in Fast Start are more likely, in the compressed courses, are more likely to pass college math, enroll in and pass college math than students in the traditional math sequence, the longer math sequence. And Fast Start also has some non-academic supports as well. They do case management and some other, they give students some support besides just the shorter math sequence. And then the second study is Hodara and Jaggers, that's me, that we looked at the impact of shorter versus longer sequences at the City University of New York community colleges. There are 6 community colleges there, and we found that students who were in shorter math sequences were more likely to pass their college math course, or enroll and pass college math, and then there's also a very small 1 percentage point impact on degree completion. And you think 1 percentage point is nothing. That's nothing. But developmental math students who place into the lowest level of math at the City University of New York had something like a 5% degree completion rate. So if you add a 1% to that, that's 6%. So that's pretty good. And so that's, the compression is basically about shortening the sequence. And so it seems to be, based on 2 studies, limited research, a straightforward way to improve outcomes. And then we have mainstreaming, and Boatman also looked at a mainstreaming reform in Tennessee at a 4-year college in which students were allowed to enroll, students who were previously placed in developmental math were now allowed to enroll in enhanced college-level math courses. They were given a lot of supplemental support that was designed specifically with their needs in mind. There was a lot of thought into how to mainstream these students, and they've been seeing fairly positive results with credit attainment and persistence. That study didn't look at degree completion, but I combined them all here. In the brief, it's disentangled, so you know exactly what goes with what study. And then the final study is an evaluation of IBEST in Washington. And that model has also been found to be fairly promising. So IBEST is, what it is it's at 2-year colleges, at community colleges, and an occupational instructor will team teach with a basic skills instructor. They're required to team teach at least 50% of the time. And so all the basic skills instruction is integrated into a college-level occupational or career technical course. And so that's reading, math, writing, everything. So students do not take non-credit bearing courses before they get into their college-level courses. And that program has been found to have a positive impact on their persistence and attainment of certificates, not associates or bachelors. So these are occupational programs. Okay. That's a lot of evidence. There you go. And here we are, your turn to talk. So, what are your experiences with reforms to developmental math programs? And what do you think is key to developmental math students' college math success, and how can developmental math reforms address these key factors? So, what's missing from some of these reforms that I just talked about that is really important? So go ahead, and I look forward to hearing from you all in a little bit. I'm going to focus on two strategies that have some research that I thought the studies were fairly good, not randomized controlled trials, but pretty good. There's a pretty good job at making sure that students who receive the instructional strategy and students who didn't were similar. So one of them is structured student collaboration. So this is basically just cooperative learning. And a lot of people do cooperative learning. I'm doing it now and you've been doing it all day really. But theories and research around cooperative learning say it's not just about people, two people coming together and talking. You really have to have some structure, some formal roles and responsibilities. And that's when people really benefit from cooperative learning. So we're going to look at that. And then the second one is using multiple representations, which is what the visual is looking at. It's when you solve math problems and think about math problems in multiple ways, symbolically, graphically, with words, with tables, with graphs, with equations, formulas. And that's supposed to, improve your conceptual understanding. And so it's not clear how common these are across the country in post-secondary math classrooms. There's really no national scans like the other interventions and reforms I talk about. There's literature on how common are these, but there isn't anything about what does post-secondary math instruction look like across the country. There are some qualitative studies that took place in California, and what they found is, for the most part, in developmental math classrooms in community colleges, it was lecture-based, it was skill and drill, it was problems that were devoid of application to the math students use in their degree programs or in their everyday lives. And so this strategy is about, there is no project-based learning here, but that's because I didn't find any studies on it, but this is about, something different than that. And so we'll talk about that now. All right, so there's 3 studies, and there's a couple of studies on structured student collaboration. They're a little bit older, but I think they were pretty well done. And in both of these were both developmental math classrooms that used fairly kind of simple pedagogical changes to the classroom to make sure that students were in groups and had roles and responsibilities when solving math problems. For example, one in the D study, basically they broke up the problem and each person had a part of it and had to put the problem together to figure out what the problem was asking and then solve it together. So it was fairly simple. And in both studies, they found that students had higher pass rates, developmental math pass rates, or were performing better on exams that tested their mathematical understanding and achievement. Those studies, none of these studies looked at anything except for what was going on in that classroom at the time. They didn't look at long-term outcomes, so we don't know. But both studies show that these small changes seemed to have a significant impact on students' math learning. And then the last study, using multiple representations, this was another, I thought, really interesting one to read, and I really liked how they implemented the research study. This took place in a college calculus classroom, and so they had classes where faculty were given some professional development around making sure students were learning and solving math calculus problems in multiple ways. And then they had other classrooms where teachers were using the traditional textbook, going through it in a linear manner. Students were, there's more of a focus on procedural learning. And at the end, they gave all these students the same types of tests. They gave them all sorts of they gave them a multiple choice standardized exam. They gave them some open-ended questions. And students in the classrooms that emphasized multiple representations did much better. And they're also able to answer questions that had never been introduced, which means they're transferring the skills they learned to other concepts. So not a very surprising finding, I think, but something that kind of might validate what people think about how to teach math. So that's it. So I'm gonna, we're gonna talk about that. So that's it for the research, and so we're gonna talk about this, and I'm gonna go over one more slide about, with some final thoughts. But the two questions I have are, what are your experiences with trying different math instructional strategies and our curriculum? And then the last one is, what can developmental and college math faculty learn from effective math teaching at the secondary level? And what can developmental and college math faculty learn from each other? And is it even appropriate? Is what someone does in a special education classroom in high school that really works for students who have an IEP and have math deficits, is what that teacher does okay to take and adapt and use in developmental math? Or is what something really great that's going on in a college calculus classroom, is that okay to take and adapt to a developmental math classroom? And if yes, what's going on across sectors that we can learn from each other and take and use to improve students' college math success? Okay, so just to end, I'm just going to talk about the final considerations based on this research. I mean, it is limited, so it's hard to kind of come up with some revolutionary findings, but you can kind of, glean some sort of lessons from all this research that's been done. So one is that, if a lot of these programs are having a limited impact that's limited to that semester or time in which students are actually in that intervention, then like you all have thought about, these interventions need to be connected to like a broad set of interventions that are happening throughout students' cradle to career, ideally, but at least, high school to college. So, when you're thinking about system level policy, you want to design and offer all students a connected, comprehensive, and cost-effective set of supports from high school into college. And that's how you're really going to reduce rates of remediation. It has to start in high school, and it has to go into at least their first year, and has to include all sorts of different types of interventions and supports, which is hard to do. But like you said, if there's a funding structure that's, not burdening one particular sector institution, it makes it easier. And then second, thinking about developmental education reform. So what a lot of people, what's happening across the country is, shortening the sequence, or having students who would have been developmental education co-enrolling in a college-level math course, where, in thinking about this reform, it's really important to also attend to students' non-academic needs. And so a lot of the research on things that have a really positive impact have other supports. They have case management. They have really intensive tutoring and supplemental supports that are targeting students' exact academic deficits, even financial aid. IBEST actually has financial aid help for students. So when we talk about a positive impact of IBEST, you have to think about students are getting some financial aid support as well. And this brings up a kind of a newer reform, the statistics pathways, in which they eliminate the remedial algebra sequence, and instead you have a 1 semester long remedial statistics course. They don't call it remedial, it's pre-stats. That leads into a transfer level college statistics course. It's a year-long sequence where non-STEM students can get their college level math course and complete it. And what it does is it's completely project-based. It's completely math that students use but to read the newspaper and understand what they're reading when they look at a percent. Talks about the difference between a correlation and a causal inference. All sorts of kind of math skills that you want in your everyday life, and it's for non-STEM students. And that's something that's happening in California a lot and some other states, and it hasn't been studied in a rigorous way, but it's definitely one that is thinking about other things besides just shortening the sequence. And it also explicitly talks to students about, if you make a mistake, it's okay. That's a part of learning. That means that you're actually approaching challenging work, and that's important. And then the last is just classroom level change and thinking about integrating effective math pedagogy into all these interventions. And that is where I will end so we can have the panel.